about some of the amazing objects in our night sky. Tonight, I am going to be reading to you about a very special moon in our solar system. So special, in fact, that NASA is going to be launching another mission in October of this year, 2024, to investigate a little bit better. So first, we are going to look at some of the basics about the mission. Then we will look at some of the fantastic 3D renders that the NASA website has. And we will then finish up by reading about the moon itself. If that sounds good to you, then I would appreciate it if you would give me a like and subscribe. Okay, let's get started. Okay, I'm sure you could tell from the title because you're watching this channel, so you're obviously a very smart person. I'm sure you know from the title that tonight we are going to be talking about the moon Europa. Is one of Jupiter's moons. So, let's find out why it's so special. This is all on the NASA website, by the way, and I will be giving links to everything in the description box below if you want to check anything out for yourself. Scientists are almost certain a vast ocean lies beneath Europa's icy shell. In 2024, the journey begins. Clipper is being crafted with one overarching goal: determine if Europa harbors conditions suitable for life. Why Europa? Europa has the ingredients essential for life: water, chemistry, and energy. So, this right here is just something that I struggle to grasp so much. This moon, you see this? This is all water. That's all water. The whole moon is covered in water. You know, I've only ever been to Earth, so I can't imagine an entire planet covered in water. Or, well, I guess this is a moon, but this whole moon is covered in water, and then it's just got it's got a shell of ice. And that's what this, like, brownish colored thing is, but all of this is water. Liquid water is essential for the complex chemistry that makes life on Earth possible. Scientists predict a salty ocean lies beneath Europa's surface, which has more water than Earth's oceans combined. Chemistry. The chemistry of life relies on elements that are common in the universe. For Europa to be habitable, it needs the essential building blocks for life: carbon, hydrogen, oxygen, and sulfur, to name a few. Energy. How does an icy moon far from the sun get the energy needed to sustain life? Jupiter's strong gravity creates tides on Europa that stretch and tug the moon, producing heat. Okay, this is a quote from one of the scientists on the Europa Clipper mission, Robert Pappalardo. If there is life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond. Okay, so if you've been watching me for a little while now, you know that I love these virtual 3D renders that NASA has. So this is Europa, and I can't remember exactly where I read it, but I read somewhere that Europa has like one of the smoothest surfaces of any planet or moon in the solar system. So I guess that would make sense if it's covered in ice. But okay. It's got an interior button. Are you ready? This is exciting. Isn't that trippy? Look, it's got an iron metallic core, and when they say that it's metallic, they really mean it, don't they? Okay, so it's got an iron metallic core, a rocky interior, and this blue line that goes all the way around the moon. That's the ocean, and this white is the ice shell. Let's learn a little bit more about the layers. The iron metallic core. The exact size and composition of Europa's iron-rich core is unknown, but measurements of Europa's gravity and composition from the Europa Clipper mission should help scientists home in on its diameter. Rocky interior. Rocky interior. Europa's rocky interior lies between the moon's core and the ocean layer. As with Europa's core, its exact diameter is not precisely known. As Europa flexes due to the gravity of Jupiter, ocean water might seep into the uppermost portion of the rocky layer to be heated and interact chemically with the rock, loading the water with minerals and organic or carbon-containing compounds as it flows back into the bottom of the ocean through cracks and fissures. Such a process could supply the ocean with the building blocks for life and with materials that could serve as food for simple organisms. I guess I should credit the artist of these renderings here. Certainly don't want to, this person did a good job. They deserve credit for their work. ocean and the ice shell. Let's see about this ocean here. Okay, let's learn about the ocean. Several independent lines of evidence have led scientists to conclude that Europa almost certainly has a global ocean of salty liquid water beneath the icy crust. In this cutaway, the ocean may appear thin relative to the moon's overall size, but is thought to be 40 to 100 miles or 60 to 150 kilometers deep and contain more than twice as much water as all of Earth's oceans combined. Okay, so we've worked our way out from the center, from the iron metallic core. Let's click on the last one, the icy shell. Okay, this is the last layer, the icy shell. And this doesn't have a credit. Well, I mean, it credits NASA and the Jet Propulsion Laboratory. I don't know if it's safe to say that this is drawn by that Michael Carroll person or not. Either way, great job, Michael Carroll. Anyway, the icy shell. Scientists estimate that Europa's outer icy shell is 10 to 15 miles or 15 to 25 kilometers thick and sits atop a salty ocean of liquid water. Unlike Earth's rocky crust, Europa's surface is almost entirely rock-hard water ice with a small fraction of briny material and perhaps organics mixed in. If Europa's exterior is being deformed by forces acting on its shell, what scientists refer to as being tectonically active, then ocean material may be able to reach the moon's surface and vice versa. Before we move on, I did just want to show you that if you would like, you can go to the NASA website and you can send your name to Europa on the Clipper mission. Now, there is a catch. Supposedly they quit taking names on December 30th. However, the website is still up and you can still fill out the form. So I don't know if they're honoring that December 30th deadline or not. It doesn't hurt to try. I'll try to be better about reminding you guys or letting you guys know about stuff like that. Alright, I hope you guys are enjoying this and finding it as interesting as I do. I hope you're relaxed, or I hope you're at least asleep. And if not, I am going to read a little bit more about Europa itself. And if that doesn't put you to sleep, I don't know what will, because I timed myself reading it earlier and it took me about 20 minutes. So, I hope you're comfy. Okay. Decades ago, science fiction offered a hypothetical scenario. What if alien life were thriving in an ocean beneath the icy surface of Jupiter's moon, Europa? The notion pulled Europa out of obscurity and into the limelight, where it has remained, stoking the imaginations of people both within and outside the science community who fantasize about humans discovering life beyond Earth. That fantasy, however, may be grounded in reality. In 1972, scientists using a telescope at Kitt Peak National Observatory in Tucson, Arizona, made a spectroscopic observation that showed that Europa's surface composition is mostly water ice. Thermal models dating back to 1971 also suggested that the interior of Europa could contain a layer of liquid water. NASA's Pioneer 10 and 11 spacecraft flew by Jupiter in the early 1970s, but the first spacecraft to image the surfaces of Jupiter's moons in significant detail were the Voyager 1 and 2 spacecraft. Voyager 1's closest approach to Jupiter occurred on March 4th, 1979. The spacecraft snapped a full global image of Europa from a distance of about 1.2 million miles, or 2 million kilometers. Yeah, here. I mean, it doesn't look very exciting, but being that that was the very first image, it was incredibly exciting. A few months later, after that first picture was taken, Voyager 2 had its closest encounter with Europa on July 9th, 1979. Images from the two Voyagers reveal a surface brighter than that of Earth's moon, crisscrossed with numerous bands and ridges, and with a surprising lack of large impact craters, tall cliffs, or mountains. In other words, Europa has a very smooth surface relative to the other icy moons. Even though the Voyagers did not pass extremely close to Europa, their images were high enough quality that researchers noted some of the dark bands had opposite sides that matched each other extremely well, like pieces of a jigsaw puzzle. These cracks had separated, and dark, icy material appeared to have flowed into the open gaps, suggesting that the surface had been active at some time in the past. And, let's see if I can show you that. Yeah, this is the image that Voyager 2 took on the second approach. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. Okay, so I've got chemistry this semester, so I think I'm going to try and attempt to explain that. I don't know how well I understand it, but let's try. Okay, so salt is made of two molecules, is sodium and chloride. Sodium has a positive charge, meaning that it can take another electron, and chloride has a negative charge, meaning it can give another electron away. Now, when salt is introduced into water, which is a polar molecule, meaning that it can take or give electrons, it dissolves the sodium and the chloride into two different molecules. It just separates the molecules. So, electricity can then hop from molecule to molecule with all of the different positive and negative charges, and that's why salt water is such a good conductor of electricity. Therefore, that would explain the magnetic field. Watch me be totally wrong. That's okay. I'm trying to learn. Scientists think Europa's ice shell is 10 to 15 miles or 15 to 25 kilometers thick, floating on an ocean of 40 to 100 miles or 60 to 150 kilometers deep. So while Europa is only 1/4 the diameter of Earth, its ocean may contain twice as much water as Earth's global ocean. Europa's ocean is considered one of the most promising places in the solar system to look for life beyond Earth. In November 2019, an international research team led by NASA announced that it had detected water vapor. It had directly detected water vapor for the first time above Europa's surface. The team measured the vapor using a spectrograph at the Keck Observatory in Hawaii that measured the chemical composition of planetary atmospheres through the infrared light they emit or absorb, if the plumes do exist, and if their source is linked to Europa's ocean. Then a spacecraft could travel through the plume to sample and analyze it from orbit, and it would essentially be analyzing the moon's ocean. NASA's Cassini spacecraft performed this feat at Saturn's moon Enceladus, which is known to have an ocean spraying into space. So Enceladus is pretty cool. The very first episode that I did on my channel, or well, I guess the very first is official ASMR video for the Spaced Out ASMR channel was over Saturn, and we looked at Enceladus and its little water jet on the side, so that was really cool. It's a lower quality video, but I guess if you're curious about Saturn, check it out. Even if Europa isn't ejecting samples into space, a 2018 study concluded that samples of Europa's ocean could get frozen into the base of the moon's ice shell, where the ice makes contact with the ocean. As ice shell distorts and flexes from tidal forces, warmer and less dense ice would rise, carrying the ocean samples to the surface, where a spacecraft could analyze it remotely using infrared and ultraviolet instruments, among others. Scientists could then study the material's composition to determine whether Europa's ocean might be hospitable for some form of life. Europa's surface is blasted by radiation from Jupiter. That's a bad thing for life on the surface. It couldn't survive, but radiation may create fuel for life in an ocean below the surface. If we eventually find some form of life at Europa, it may look like microbes or maybe something more complex. If it can be demonstrated that life formed independently in two places around the same star, it would be reasonable to suggest that life springs up in the universe fairly easily once the necessary ingredients are present, and that life may be found throughout our galaxy and the universe. Size and distance. With an equatorial diameter of 1,940 miles, or 3,100 kilometers, Europa is about 90% the size of Earth's moon. So if we replaced our moon with Europa, it would appear roughly the same size in our sky as our moon does, but brighter, much, much brighter. Europa's surface is made of water ice, and so it reflects 5.5 times the sunlight than our moon does. That's probably one of my favorite facts so far, that Europa is almost 5 times brighter, but absorbs much less radiation because it's so far from the sun. Because of the distance, sunlight is about 25 times fainter at Jupiter and Europa than at Earth. Orbit and rotation. Europa orbits Jupiter every 3.5 days and is locked by gravity to Jupiter, so the same hemisphere of the moon always faces the planet. Jupiter takes about 4,333 Earth days, or about 12 Earth years, to orbit the Sun, a Jovian year, Jupiter's equator, and the orbital plane of its moons is tilted with respect to Jupiter's orbital path around the Sun by only 3 degrees. Earth is tilted 23.5 degrees. This means that Jupiter spins nearly upright so that the planet, as well as Europa and Jupiter's other moons, do not have seasons like the Earth does. Jupiter's moons, Io, Europa, and Ganymede, are in what is called a resonance. Every time Ganymede orbits Jupiter once, Europa orbits twice, and Io orbits 4 times. Over time, the orbits of most large satellites or planets tend to become circular. But in the case of these 3 satellites, the resonance produces a forced eccentricity. Since the satellites line up with each other at the same points in side. The magnitude of this difference changes as Europa orbits, creating tides that stretch and relax the moon's surface. Flexing from the tides likely creates the moon's surface fractures. If Europa's ocean exists, the tidal heating could also lead to volcanic hydrothermal activity on the seafloor, supplying nutrients that could make the ocean suitable for living things. Formation. Jupiter's large Galilean moons, Io, Europa, Ganymede, and Callisto, likely formed out of a leftover material after Jupiter condensed from the initial cloud of gas and dust surrounding the Sun. Early in the history of the solar system, those four moons are likely about the same age as the rest of the solar system, at about 4.5 billion years old. In fact, the Galilean moons are sometimes called a mini solar system, since they formed from the leftovers of Jupiter, similar to how Earth and the other planets formed from gas and dust left over from the formation of the Sun. The similarities don't end there. Each planet in the solar system is less dense than its inner neighbor. Mars is less dense than Earth, which is less dense than Venus, which is less dense than Mercury. The Galilean moons follow the same principle, being less dense the farther they are from Jupiter. The reduced density at greater distances is likely due to temperature. Denser, rocky, and metal material condenses out first, close to Jupiter or the Sun, while lighter weight, icy material only condenses out at larger distances where it is colder. Distances, or distance from Jupiter, also determines how much tidal heating the Galilean satellites experience. Io, closest to Jupiter, is heated so much that it is the most volcanically active body in the solar system. Ancient volcanic activity likely long ago evaporated any water it had when it formed. Europa has a layer of ice and water on top of a rocky metal interior, while Ganymede and Callisto actually have higher proportions of water ice and lower densities. So, I never realized that the planets get less dense the farther you go out. I guess that would make sense because, that fact about Saturn being the least dense, so it could actually float in a tub of water. I guess that makes sense, but aren't Neptune and Uranus after Saturn? Distance from Jupiter also determines how much tidal heating the Galilean satellites experience. Io, closest to Jupiter, is heated so much that it is the most volcanically active body in the solar evaporated any water it had when it formed. Europa has a layer of ice and water on top of a rocky and metal interior, while Ganymede and Callisto actually have higher proportions of water ice and lower densities. Structure. Like our planet, Europa is thought to have an iron core, a rocky mantle, and an ocean of salty water. Unlike Earth, however, Europa's ocean lies below a shell of ice probably 10 to 15 miles or 15 to 25 kilometers thick and has an estimated depth of 40 to 100 miles or 60 to 150 kilometers. While evidence for an internal ocean is strong, its presence awaits confirmation by a future mission. Okay, I brought my screen back out because I wanted to show you this close-up of the surface. Let's see, where's the credit on this image? The credit just says NASA/JPL or Jet Propulsion Laboratory / University of Arizona. Surface. Europa's water ice surface is crisscrossed by dark reddish brown cracks. Based on the small number of observable craters, the surface of this moon appears to be no more than 40 to 90 million years old, which is youthful in geologic terms. The surface of Callisto, another of Jupiter's moons, is estimated to be a few billion years old. All along Europa's many fractures and in splotchy patterns across the surface is a reddish-brown material whose composition is not known for certain, but likely contains salts and sulfur compounds that have been mixed with water ice and modified by radiation. This surface composition may hold clues to the moon's potential as a habitable world. NASA's Galileo spacecraft explored the Jupiter system from 1995 to 2003 and made numerous flybys of Europa. Galileo revealed strange pits and domes that suggest Europa's ice layer could be slowly churning or convecting. Cooler, denser ice sinks, while warmer, less dense ice rises. Due to heat from below, long linear fractures are often only about a half mile to a mile wide or 1 to 2 kilometers wide, but can extend for thousands of kilometers across Europa's surface. Some of these fractures have built up into ridges hundreds of meters tall, while others appear to have pulled apart into wide bands of multiple parallel fractures. Galileo also found regions called chaos terrain, where broken, blocky landscapes were covered in a mysterious reddish-brown material. In 2011, scientists studying Galileo data proposed that chaos terrains could be places where the surface collapsed above lens-shaped lakes embedded with ice. very tenuous amount of oxygen. But in 2013, NASA announced that researchers using the Hubble Space Telescope found evidence that Europa might be actively venting water into space. This would mean the moon is geologically active in the present day. In November 2019, an international research team led by NASA announced it had directly detected water vapor for the first time above Europa's surface. If the plumes do exist, and if their source is linked to Europa's ocean, then a spacecraft could travel through the plume to sample and analyze it from orbit, and it would essentially be analyzing the moon's ocean. NASA's Cassini spacecraft performed this feat at Saturn's moon, Enceladus, which is known to have an ocean spraying into space. Magnetosphere. One of the most important measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted by the space around Europa. The measurement strongly implied that a special type of magnetic field is being created or induced within Europa by a deep layer of some electrically conductive fluid beneath the surface. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water, and this magnetic field result is still the best evidence we have for the evidence as an ocean, or the evidence of an ocean on Europa. Alrighty, StarStuff. That's all I have for you tonight on the Clipper mission to Europa. I hope you enjoyed it, but I would be delighted if I was able to put you to sleep. I would like to say thank you all for all of the support you guys have given me over the past few days. It's been more than I've expected, and I truly appreciate it. I also want to thank you for joining me tonight, and I hope that you have a good night. Peace and love. Good night. Good night. Good night. Good night. Good night. Bye-bye. Okay, actually, just one more thing before I go. So I just found this and it looks really, really, really neat. It's the Augmented Reality, Europa Clipper Augmented Reality Experience. Yeah, I guess I'm gonna download that on my iPad later. So, I know this is a total ADHD moment, but yeah, that looks cool. You should check it out. I'm gonna check it out. Let me know what you think. Okay, so I am gonna go turn my heat back on now. And good night for real. Good night.